Hi, good morning, everyone. So today, let's work on another LeetCode quiz. So first, we look at the question we need to solve. Minimum cost path with alternating directions. You are given two integers, m and n, representing the number of rows and columns of a grid, respectively. The cost to enter cell ij is defined as I plus 1 multiplied by j plus 1. You are also given a 2D integer array, waitCost. Well, waitCost ij defines the cost to wait on that call. The path will always begin by entering cell 00 on move 1 and playing the entrance cost. At each step, you follow an alternating pattern on odd-numbered seconds. You must wait in place for exactly 1 second and play waitCost ij during that second. Return the minimum total cost required to reach m minus 1, n minus 1. Okay, so here are 3 examples. Let's see how it works. Yeah. Let me check what's okay, the headset connected. Good. So input m is 1, n is 2, waitCost is 1, 2. waitCost, what's waitCost? Okay, the cost to wait in that cell. Okay, 1, 2. So the path is start a cell 0, 0, 0 at second 1 with entry cost is equal to 1. Okay. So the cost to entry cell is defined as this. Okay, it's kind of like, okay, it's kind of like open a door and there's a cost to open the door. And second 1, move right to cell 0, 1 with entry cost 2. Okay, so the total cost is 3. Okay, so actually our input is 1, 2, which means that in the grid, our destination is 0, 1, okay? Example 2, the input m is equal to 2, n is equal to 2. waitCost is 3524. In this situation, our target cell is 1, 1. waitCost, let's see. When should we have waitCost? Okay. So on even number, you must wait in place for exactly 1 second and pay waitCost during that period. Okay. So we start at cell 0, 0. Okay, the entry cost is 1. And in second one, we will move down to cell 1, 0 with entry cost 2. In the next second, we will wait at this cell and pay a cost. Waste 1, 0. Waste 1, 0 is 2. Waste 1, 0, but it doesn't tell me. It doesn't tell me how to calculate waste cost 1, 0, huh? Let me see. Wait on that call. But wait, here we need to wait in the cell waste 1, 0. But what is given here is waste cost is 3524. What does that mean? I wonder, does that mean the waste cost is equal to entry cost? But if so, what's the meaning to write this? Weight cost is equal to 3524 in the input. I think it doesn't make sense, huh? Then the next step, move right to cell 1, 1. Entry cost is 4. Then we calculate them together. Okay, the last example. Input is 2, 3. So our destination will be 1, 2. And the waste cost is 614325. Ah, what does this mean? So start at 0, 0. Entry cost is 1. Then move right to cell 0, 0, 1. The entry cost is 2. Next second, wait at cell 0, 1. Wait cost is 1. Wait cost is 1. Oh. I got it. So the wait cost is actually is a 2D array. Oh yeah, he already mentioned that. It's 2D array. Say so 0, okay, 0, 0, 1 will be 1. And here 1, 0. 1, 0 will be 2. Makes sense. Makes sense. Seems clear now. Okay. Yeah. And then next step, move down to cell 1, 1. Entry cost is 4. Next step, wait at cell 1, 1, paying the wait cost 1, 1, which will be 2. Yeah, makes sense. Move right to the cell 1, 2, and with the entry cost 6. Okay. I think that the basic idea is pretty straightforward now. And let's say, so I think that the first step we want to, because it's maybe not very straightforward for everyone to directly, think of a very comprehensive solution in the first place. So I think that a, a good practice for, at least for myself, is to, start from a specific example and try to generalize the strategy I used in that specific test case. So let's start with a test case. Test case. Let's say given or input, let's say m is equal to 3, n is equal to 3, right? So we need to actually go to the bottom right corner, and let's make the waste cost is equal to, actually it's it's a 2D array, right? Let's say 5, 1, 2, 4, 3, 1. Just get some random number. Okay. Then, right, the first step, what do we need to do? We need to calculate the cost for each cell, right? So calculate cost for each cell. So the calculation for each cell will be what? Entry cost plus wait cost. Make sense? And that's relation Q2 don't lead with the cost. Wait cost, right? Okay, let's start. So we start at 0, 0. Then we maybe move down. Then we move down. Because go right and go down, there's no difference for the entry, right? The main difference is wait cost. So actually, what we need to do is we calculate for every cell. Right, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. Right? So we need to calculate the cost for each cell. The cost will be 1 multiple 1 plus 5. So it will be 6. And this one is 1 multiply 2 add 1, so it'll be 3. And this one 1 multiplied by 3 plus 2 will be 5. Then this will be 2 multiply 1 plus 4, 6. This one will be 2 multiply 2 plus 3 will be 7. Will be 2 multiply 3 plus 3 is equal to, wait. Oh yeah, plus 1 is equal to 7. This is 3 multiple by multiple 1 minus add 2 is equal to 5. 3 multiple by 2 plus 哦 no, this should be 1. Yeah, this should be 2. And the last one will be 3 multiple 3 plus 哦 yeah. But because for the last one, distillation, we actually needed to add the cost, right? So we don't need to add the cost at all. So just 9. Let me see, was this correct? Okay, yeah. Okay, so now we get the cost to entry and weight in each cell. Okay, and then we need to find the shortest path. How do we do that? We can maybe use dynamic programming to compute minimal path sum. Right? Is step 2. Step 3. After we find the minimum, yeah, we just return, minimum of the cost. Okay. Okay, so let's say we have 3 inputs. The first input is the first parameter is int, second parameter is int, third parameter is list int. Okay, and return is int. Good. And based on the strategy we propose in the test case, we start from okay, we can store infinite in IF in variable. So let's define a float infinite. So the infinite is kind of like upper bound. And then what we need to do? We need to create a 1D dynamic programming array, right? To hold the minimum costs. So we need to use infinite multiple by n. To create list of less n. So dynamic. Okay, now create a list. And in this list, it's full of infinite value. Let's say 10,000 million, 1,001 million, 1 trillion, 1 billion, whatever. Then what do we need to do? We need to loop over each column in the first row, right? Right, because now we start calculating the costs. So for j in range n, we want to calculate the enter cost, right? And costs. So this is the first row. And also we need to figure out the waitCost, right? So we need to decide if this cell is distillation, right? If it is distillation, no waitCost. If not, we need to add an extra cost. So extra weight is equal to 0. If what? If m minus 1 is equal to 0 and j is equal to n minus 1, right? But if not, then we add waitCost. Make sense? Then the weight will be end cost plus extra weight, right? Straightforward. Then what do we need to do? Right, so if first cell in the row, right, if what we need to is get the first cell in the row, so if first cell in the row, we need to set starting dp0 to weight of 0, 0, right? Because remember yesterday when we talk about dynamic programming, we mentioned that we need to, initialize the start point first. So dp0 will be weight. Make sense? Else, right? If not, then we need to accumulate weight from left cell to our destination, right? So if not, we will accumulate weight from left cell to our destination. Correct. So it would be dpj is equal to, no, dpj equal to dpj minus 1 plus weight, correct? And then we go through the first row, and then let's go through the other rows. So let's loop rows starting at 1, right? So for we always pay attention to the incident. For I in range 1m, then what we need to is pretty similar to above, right? We have end cost and we have weight costs. also let's add them together. And updates the DP0. So make sense? Now we can handle other columns. And handle columns J from 1 to n minus 1. Similar strategy, huh? And the costs. And waitCost. Final costs. So now, deep J. Dynamic program deep J holds the costs from cell above, right? From cell above. Deep J minus 1. all the costs from the cell to the left. Right? And then we need to choose the cheapest left and above and add current weight. So if J is equal to minimum, if J minus 1 and add final weight. So after we filling the dynamic programming, then diff n minus 1 holds minimum total cost to reach destination. Right. So what we return is diff n minus 1. Yeah. So the key idea is to, from this example, I think it's pretty straightforward. But what we need to figure out is how to deal with the dynamic programming strategy. Anyway, let's try to run it first. Okay. So this is line 14. What's wrong with it? Actual weight. Oh, start from 1 to the n. I equals to m minus 1. J is n to 1. Okay. Oh, okay. Oh, let's start. Oh, is equal to same issue. Yeah. Mm. Mm. There's one difference. Wow. Start from top. Maybe there are some tuple here, I assume. So we start from our beginning. Define a dynamic programming. Go through the range and cost, actual weight. Mm. I'm thinking whether I have some wrong indecent again. How to say that? Indecent.
Indentation.
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 Indentation. Okay. Maybe I have some wrong indentation. I'm not sure. Mm. Indentation. Mm. Let's ask GPT for help. Well, the bugs for the code. Okay. We get multiple bugs. First row initialization, bug 1. Fix. Okay. Meaning the rest of the script. I make J is supposed to represent the mean from out. So the correct logic will be div J, alt J plus cost. So what do we need to do? We need to find previous dynamic. Okay. Does it work? So I guess the main issue is okay. Okay, I guess the main issue looks like the issue is DPJ. And his main idea is that we should have a previous dynamic here, even before the start. So here it define a previous dynamic. And here, instead of minimum dpj, it's use previous j. Not sure whether this works, but let's see. No. So it feels like it's not this issue. Here have bugs. Okay. Put it in the range. Okay. Nope. Still doesn't work. previous 0. Okay, previous. Inside the inner loop. Two buffer. Mixing old and current in one array. New array per row. Or update. If you want to give a revised code, please only minimize your edits. Keep everything else in my original code. Right, because It's actually rewrite the whole thing, and that's not what I expected. Okay, use previous. Wait. I guess I already did this right. Right, db0 is equal to previous 0. I have done this. That's confusing. Wait, I already update. Already update. Wait. Wrong answer. So you see, sometimes use ChatGPT debug is not a pretty good idea because it's, well, I guess I shouldn't use ChatGPT for debugging, maybe. Maybe should use cloud because cloud is more logic. Yeah, I think that's something I should try. Which line you change? Also exclude weight at start 0, 0. Oh. I get the point. For the start, we also shouldn't wait, huh? I guess we find well the reason. Yeah, or it says the very beginning. Yeah. Hey, what are you doing? So you see, at the very beginning, actually ChatGPT doesn't find the reason correctly. I think that this is the main reason, right? So when j is equal to 0, which means it's the beginning. In this case, we should also, yeah, so you see. So what's the point here? So sometimes, when you say there's a bug, you should tell. So the lesson here is that when there is a bug, we should also tell ChatGPT what's the output in case that it finds some random issues. Okay, runtime is pretty nice. It's O M multiple N and space is ON. Interesting. Okay, yeah, I think that's pretty much for this question. Thank you, everyone. Bye.